It was an unseasonably warm fall day as I drove out to the Westinghouse Waltz Mill facility, about 40 miles southeast of Pittsburgh.
We have a control room simulator back there.
I had an exclusive opportunity to visit the site to learn about the company's eVinci nuclear microreactor. The engineers I met on site spoke excitedly about eVinci, which is in mid-design. Mike Shacko is Senior VP for Advanced Reactors at Westinghouse.
I've been in this industry for many years. This is the most exciting time I feel that we've been in.
Westinghouse touts eVinci's solid core and advanced heat pipes, which enable passive cooling and allow for autonomous operation and load following. There is no pumping of water or gas. Therefore, the company considers eVinci as more of a nuclear battery.
We're designing the core, the passive system aspect of the nuclear reactor that we have in eVinci, as well as the power conversion units, to be able to adjust and meet those demands, those fluctuating demands in 24 hours.
Pipes embedded in the core transfer heat from one end to the other, where it is captured in a heat exchanger. For cooling, each heat pipe contains a small amount of sodium liquid to move heat from the core and is fully encapsulated in a sealed pipe.
We know it works. It's been demonstrated by national labs, especially Los Alamos National Lab. That's where the initial concept of heat pipe came from.
At Waltz Mill, engineers are still testing eVinci's heat pipes to demonstrate their performance limits. Because of the proprietary nature of the design process, I'm not able to show or explain every detail. But to this point, Westinghouse has a scaled-down prototypic cell of the eVinci reactor and used electric heaters to simulate temperatures that it would get from nuclear fuel.
We mocked up one of these cells of our reactor, and we ran those heat pipes up to our full operating temperature. And we were able to validate analysis and modeling codes, and we were able to show that our heat pipes really in this cell will transfer the right amount of heat and in the ways that our analysis and modeling codes expected.
Westinghouse looks to remote communities as the entry market for eVinci. It could replace diesel as a power generating fuel, which is expensive to transport, often hundreds of miles. eVinci can generate 5 megawatts of electricity and 13 megawatts of heat, with exhaust heat from the power conversion system that can be used for district heating or low-temperature steam.
I really believe it's going to be disruptive at some point in time. It's the ability to take that experience, that knowledge, and take it to the next level. Yes, we do need the grid-based large reactors. We need the SMRs. And we see the microreactors as the way to complete that circle.
This is Kevin Clark for PowerGen and Power Engineering.